So in this video, we're going to be using rationalizing the numerator to find the slope of the tangent line, or our derivative, to this curve. Now, before we would just plug in 2 into x and be able to do our f of 2 minus h, right? Plus h. But what we're going to be doing here is we're going to make a formula, because I don't want to have to plug it in for 2 and find the slope of that tangent and then do it all over again with 0. That'd be a lot of work. So what we're going to do is take the slope of the secant, we're going to leave it alone. We're going to leave it as x plus h minus f of x. And if you do this for every single problem, what you're doing is creating a formula that you can use to plug in any point. So if we leave f of x plus h minus f of x, first thing we have to do is find f of x plus h. So we end up with the square root of 2x plus h plus 5. And then that ends up with the square root of 2x plus 2h plus 5. And so now we take our f of x plus h, we subtract f of x, and then we divide the whole thing by h. So on this, you'll notice they don't cancel. That's why we're going to be using rationalizing the numerator. It's a trick that we can use. And so now right now I'm just plugging everything in all over h. So our f of x plus h is this. Our f of x is this, and we're dividing the whole thing by h. So here's the trick. This h is what we have to get rid of. This needs to go. Because when we get down to the limit, as h approaches 0, we do not want a h here, because then we're going to get undefined. It's not good. So we're going to be using a trick called rationalizing the numerator. And so we take and we use the conjugate, 2x plus 2h. So whatever your numerator is, you want to use a plus if it's a minus and a minus if it's a plus. And since we're using difference quotient, that's going to be a minus. So 2x plus 2h plus 5 plus square root of 2x plus 5. All right, and we're going to leave this alone. So again, the goal is to get rid of h. We don't want to distribute it. Just leave this where it is. Now, if you remember difference of squares, we're only going to have to multiply the first with the first and the last with the last, because the middle terms are going to cancel. Because this outer 2, we're going to give a positive version of the inner 2, which is a negative. So that times that minus that times that, which is the same thing. Those just cancel. So all you have to do is first times first. And so that would end up with 2x plus 2h plus 5 minus, and then rad 2x plus 5 times rad 2x plus 5 is also 2x plus 5, because you end up with a pair. And so this is now the slope of our secant all over that horribly messy thing. I'm going to leave this in red just to signify that you do not want to touch it. It's just going to be there for the rest of the problem. All right. So now if you notice on the top, by doing the conjugate, we broke open the radicals, which allow us to cancel these now, because now they are just polynomials, like terms, they cancel. And so the 2x take away 2x and the 5 take away 5 would cancel, leaving us with just 2h. And see, now it's just h on top with an h on the bottom. You see where everything's going, hopefully. And so now we can cancel the h as well. And so now we have the slope of our secant. Remember, once you cancel that h, you're done with the secant. And then now we can move on to the tangent. So slope of tangent, this is our formula now. So remember, it's just the limit of the secant. So limit as h approaches 0 of 2 over the square root of 2x plus 2h plus 5 plus the square root of 2x plus 5. And our h becomes 0, giving us 2 over the square root of 2x plus 5 plus the square root of 2x plus 5. So that's 2 of them. So we have 2, right? There's 1 here and 1 here. So together they make 2. And then we can even do some more now, some more canceling. So we end up with 1 over the square root of 2x plus 5. So now we have a formula for our tangent. This means that we can plug any point we want in. It'll tell us the slope at that point. So we're going to start with 2, 3. So this is our x, this is our y, and we just plug it in. So slope of the tangent, and in fact we should now write it what it is. So f prime of 2, because that's our x value we're plugging in. This is f prime of x, right? This is f prime of x equals. So f prime of 2 would just be 1 over square root of 2 times 2 plus 5, which is 1 over the square root of 9, which is 3. So the slope of the tangent to the curve of f of x square root of, which is equal to square root of 2x plus 5 at 2 comma 3 is 1/3. And then now we do it again with the next point, 0 square root of 5. And so f prime of 0 would be 1 over the square root of 2 times 0 plus 5, which is 1 over the square root of 5. And so that's your answers. So just to look at it with Desmos, again, let's look at just the first one. This is 2, 3. So if I plug in 2, I get the 0.23. And again, we made a formula for the secant. So right now, this is an h of 1. So if you took that formula here, right here for the slope of the secant, right here, and you made the h1 and the x2, it would give you the slope of that line. Now, our h is approaching 0, which gives us our derivative. I have the equation that we found, and there it is. You see they match perfectly. And there you have it. Thank you.